Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationcity.com. In this video, we are talking about the prime-dual simplex method and how does it work. Let's go on.
The prime-dual simplex method is used for the problems that are both infeasible and non-optimal. Unlike the other method, it means the simplex and prime simplex and dual simplex. This algorithm does not require the addition of any artificial variable. That's very important point. It combines the concept from the prime simplex and dual simplex. Note that there is a different variation of the prime dual simplex method. We pick one of them. So what is the algorithm of the prime simplex methods? In step one, we convert the problem's constraint to the smaller or equal form and transform the objective function to maximize. In step two, we introduce the slack variable to constraint and set up the simplex methods. In step three, we calculate the effect of the objective function using either the prime simplex or dual simplex. There are two cases here. The first case is prime simplex effect. In this effect, when there is a variable with the negative coefficient in row 0 and the pivot column's number and the number on right hand side opposite that number are non-negative, we calculate the effect like this. So there is another effect. It's called dual simplex effect. When there is a variable in the row 0 with the non-negative coefficient and the pivot column number and the number of right-hand side opposite that number are negative, we calculate the dual simplex effect like this. In step 4, we choose the largest absolute value calculated from the effect the prime and simplex prime and dual simplex as mentioned in step 2. Step 3, follow the prime and dual algorithm accordingly. If neither can be applied, the process is finished. Otherwise, we return to step 3. So let's look as an example, a very important example. We will follow the prime dual simplex methods. Follow the step 1 and 2. We transform the model accordingly. So it means we should first we multiply constraint 1 and 2 by -1 and then add the slack variable, so we have this model. Next, we calculate the prime simplex effect based on a negative coefficient of x2 in row 0, which is -6, and the present of the only positive number in this row is 5, and the positive number of right hand side is 35. The calculation is as follows. So here we have 35 as a bi here. This is a positive value, and 6 is a negative coefficient of x2 in the objective function here. This is -6. You know that you should go this part of the equation to other side of the equal, so it's very simple. So really it's -6, and 32 is 5, so it should be positive, and we add the 5 as a this part of this equation. So we have the 42 as a prime simplex methods. We also calculate dual simplex method effect, the non-negative coefficient of the x1 in row 0 here. This is the positive value. We are using this positive value for dual simplex effect. So we have 3 and 3 here, and this is the right hand side. We should be negative value, and the coefficient of the x here, x1, just behind the x1 in the objective function, so is -1 and -3. Uh, as a matter of fact, we have the two dual simplex effects. One of them is 80 and the other is 9. Since the prime simplex effect 42 is the largest among the three effects calculated above, we will proceed with the new calculation using the prime simplex methods. So this calculation is done by the following. So we do the simplex method, prime simplex method, as we state in the beginning of the course. So S3 is a living variable, X2 is a entering variable. So we do the elementary operation and we have the this table. Okay, so in this table, we cannot calculate the simplex effect as there are no negative number in the row 0. So they're all positive. However, we can calculate the dual simplex method because we have a one negative value. Since only negative value -2 is associated with the basic variable S2, okay, and only the negative number in row 2 is minus 1.6, and okay, and the coefficient of this variable in the objective function is positive, we can calculate the dual simplex effect. So this effect is the only effect in this case, is calculated as follow. Here, this is the calculation, and the dual simplex effect would be 14.25. As a matter of fact, uh, we do the dual simplex methods. And finally, in table 3, we cannot calculate. We do the elementary operation for dual simplex method in this table. So we have the table 3. In table 3, we cannot calculate the prime simplex effect as there are no negative uh, number in the row 0. Similarly, since our number of right-hand side are positive, we cannot calculate the dual simplex method effect, dual simplex effect either. Therefore, table 3 is optimal. So we reached the optimal solution. This is a very important figure. In this figure, you can see that the process of the prime dual simplex methods in the red line. So we do the two iteration to find the optimal solution. But if we follow the prime simplex method, we should do the three iteration, which is showing in green line. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by form or filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.